Hi, everyone. Welcome to our science class. Okay, today we're going to be recapping the science experiment that we just did and then moving on to learn more about how to engineer clean water. This is called Engineering Clean Water. So we will be reading this book. Now, this book is located where the readers are located by the TV. So would you grab a copy of this book so that you have it nearby? You will also need your investigation workbook. So make sure you have both of those things. If you need to pause the video in the meantime, you can. Okay, I'm going to bring up our slideshow as we begin here. All right, so let me make sure you can see me. You can. All right, excellent. Okay. Actually, I'm going to move this over to my other screen because I don't want to be looking off to the side. I think it'd be distracting to you because I have two screens at home. And if I'm looking off at the side, it's a little bit distracting. So let me make sure that I drag over. Okay. And make sure you can see me. Okay. I think you can see me in the corner now. Okay. So lesson 2.8 is all about engineering clean water. So in the last lesson, you made a freshwater collection system, and we're going to let it go and do its thing for a couple days before we measure your water. So would you turn to page 37 in your activity notebook? And your page looks a lot like this, except you have a drawing there. So we designed and built freshwater collection systems to help Mayor McKnight solve East Ferris's water shortage. So I want you to think about the different scientific ideas that were used in order to design your freshwater collection system. So just think for a moment. So we've been working with how water droplets form. So we talked about how when something cool touches something warm, the water droplets condense again. We talked about how water's always evaporating and has the water cycle. And then how did you use those ideas in your design? So yesterday, when many of you explained it, you talked about how you relied on the evaporation, which separated it from the salt water. The blue water represented the salt water. And then when it touched the top of the saran wrap or the cup, it then condenses, and then the fresh water is going to slide down. So we're going to be putting that to work when we collect that water and when we measure that water in a couple days. Now, today we will read about how real engineers are helping people in Dhaka, Bangladesh get clean water. Now, the first word I'd like to discuss with you is design. Engineers are people who design solutions to problems. Design is both a noun and a verb, and you can create a design or you can design something. So both of those are ways to use it. Now, in engineering, to design means to try to make something new that solves a problem. You designed a freshwater collection system to help solve the problem of the water shortage in East Ferris. So would you please turn to page 41 in your notebooks? I am going to be reading Engineering Clean Water to you. And as I read, I want you to record ideas from the book that will help you answer the question below. The question is, what do engineers do while designing solutions to problems? So basically, you're going to think about how they design solutions and what they do in order to design the solutions. Okay, so I'd like you to turn to page 4 in your book. engineering clean water. Okay, follow along with me while I read. Introduction. This book tells the story of how a team of engineers came together to solve a difficult problem, how to deliver clean water to people in Dhaka, the largest city in Bangladesh. Bangladesh is a country in Asia with a rich history and culture. The culture has been famous for its poetry for more than 1,000 years. People there like to say that every village has a river and a poet. Many poems describe the beautiful rivers of Bangladesh. The rivers not only inspire poetry, they also provide most of the country's water. And if you look at the picture below, that's what it looks like in Bangladesh. And the caption underneath it says, rivers provide most of the water people use in Bangladesh. Okay, page 5. Dhaka is the largest city in Bangladesh. Most people in Dhaka get their water out of shared hand pumps, which bring up water from pipes underground. Water from rivers and other sources is treated at water treatment plants and then sent through pipes to the rest of the city. The water starts out clean when it enters the pipes. However, the pipes often have cracks in them, allowing wastewater from the sewer system to leak in. By the time the water reaches the hand pumps, it is often contaminated. Even a small amount of contaminated water can make people sick. And the caption under the girl, it says, this girl lives in Dhaka. She is pumping water into a bucket to bring back to her family. And then the map underneath shows you where Dhaka, Bangladesh is. It's near India. Okay, would you turn to page 6? Engineers from Stanford University in California traveled to Bangladesh and joined up with engineers from Dhaka. They planned to work together to find a solution to this problem of contaminated water. They needed to come up with a solution that was cheap and easy to use and would work for everyone. The caption under the picture says, these are some of the engineers from the United States and Bangladesh. They walked around Dhaka together and studied hand pumps there. Sorry, it's getting late. Okay, would you turn to page 7? Learning about the problem. In order to design a solution, the engineers needed to gather information to learn about the problem. They researched how people used the water from the hand pumps and where the pumps were located throughout the city. Okay, that's one thing they did in order to solve the problem and to design it. They researched. Okay. When the engineers tested the water coming from the various pumps, almost every sample was contaminated. Next paragraph. The engineers realized that the best way to clean the water would be at the hand pumps. There would be no point in cleaning the water before it reached the pumps, since it could just become contaminated again through the cracks in the pipes. They worked on designing a solution that would clean the water right where people collected it. So there's another thing is the engineers saw where they needed to solve the problem and designed their solution based on that. So now look at the picture and underneath this picture, under the caption, it says the engineers learned a lot by talking with people in Dhaka who use the hand pumps every day. So they researched and they talked to the people involved. Okay, so now page 8. Dangerous germs were the main reason the water was making people sick. Adding a small amount of chlorine to the water would kill the germs. The engineers needed to design something to add chlorine to the water at the hand pumps where everyone got water. The engineers synthesized the information they gathered to create a list of criteria or things that their design would need to address. Their goal was to design a solution for cleaning water that could attach to hand pumps, add the correct amount of chlorine, no matter how much water flowed through, and then be produced cheaply. Now remember, that word synthesized means to bring all the information together and apply it to the problem. So that's another thing they do. The caption says, "This is Yoshika, one of the engineers from the United States. She and the other engineers tested the hand pumps many times." Okay, so then it says, let's read one more page about how the engineers solved their problem. Oh, that was the one more page. Now, we just read something that engineers do while designing solutions to the problems. On page 8, it says, in order to design a solution, the engineers needed to gather information to learn more about the problem. I now know that one thing the engineers do is to learn about their problem. This is the example, the type of idea you could record in your notebook. So here on your notebook, would you add that they need to gather information to learn about their problem? So how do they gather information? They research the problem and they talk to the people around it. Okay, so now I am going to read the rest of the book to you, and I want you to add some other ways that the engineers solve the problem. Okay, would you go to page 9? And I'll just stop sharing because the book is not here, it's here. Okay, follow along with me while I read. Planning, making, and testing a solution. Guess what, guys? They just wrote what engineers do. So engineers research their problem, they plan, they make, and they test their solution. So add that to your notebooks as well. So the engineers began to plan a solution. The first plan involved sending the contaminated water through a hose. Inside the hose, there was a chlorine-filled bag with tiny holes in it to let the chlorine slowly leak out into the water. To make this solution, the engineers bought parts from the market in Dhaka. One of the engineers from the United States, Yoshika, was staying in a place with a bathtub. The team took the parts from the market and put them together in her bathtub. They ran water through a hose and tested the water coming out the other side. And the caption under the picture says, Yoshika and the other engineers tested their solution in her bathtub. Page 10. Their tests showed that the amount of chlorine in the water varied. Sometimes too much chlorine came out and sometimes too little. Too much chlorine would make the water taste and smell terrible, and not enough would leave the water contaminated. The team had learned from their tests and needed to replan, remake, and retest. So sometimes engineers have to redo their work. This process is called iterating. To iterate means to do something many times. So you might want to add that to your notebook. Engineers iterate. This engineer is testing water samples. Okay, page 11. Iterating over and over again. Yoshika and the other engineers from the United States returned to their lab on Stanford, but they kept working on their design. The team iterated their design many more times. For each design, they planned to change one small part, make it using a 3D printer, test it to see how it worked, and then to learn from those results to make further changes. So if you look at the design cycle picture, it says learn, plan, make, test. The caption under it says, this diagram shows the design cycle. The engineers went through the cycle many times as they improved their solution. That's iterating. And then take a look at the picture of their device. It says this photo shows one iteration of the water cleaning system the engineers were working on. Okay, turn to page 12. Working in the lab allowed the engineers to change one thing at a time, like how fast the water flowed, and see how each solution responded. However, they could only do so much testing in the lab. They needed to see how their improved solutions worked at the real hand pump in Dhaka. So the engineers went back to Bangladesh to test their work. So under the caption, it says the engineers tested their solution with a hand pump in Dhaka. Page 13. One of the new solutions used solid tablets of chlorine to clean the water, but when testing the solution in Bangladesh, the engineers noticed a problem. The flow of the water from the hand pumps varied a lot, meaning it changed. Too much water flowing over the chlorine tablet dissolved too much chlorine into the water. Too little water had the opposite effect. Not enough chlorine was added to the water. After the engineers iterated on their designs several times, one of the engineers from Bangladesh, Anjurul, came up with a new way to restrict the flow of water from the pipe so that it was more consistent. That meant the right amount of chlorine always dissolved into the water, not too much and not too little. So you see a picture of Anjurul. This is Anjurul, one of the engineers from Bangladesh. And then you can see the chlorine tablets. Anjurul figured out how to get the right amount of chlorine into the water. Okay, page 14. Since he grew up in Bangladesh and used the hand pump when he was younger, Anjurul had a lot of insight into what might and might not work when people actually started using the clean water solution. He knew that people in Dhaka were used to drinking water without this extra chlorine and the treated water, which tasted a little like chlorine. It didn't taste or smell good to them. His solution of restricting the water flow from the pipes helped a lot, but the team is still working on getting people to accept the new system. The caption says, Anjurul figured out how to improve the team's solution by making the flow of water more consistent. Okay, page 15, an even better solution. Synthesizing the knowledge. So synthesizing means bringing all the information together to change your design. Synthesizing the knowledge each member brings to the team, the engineers continue to iterate on their design. Each time they iterate, their solution gets better. Now their main focus is to make their solution cheap enough to use all over the city. If this solution works for Dhaka, it might be used in other cities with water contamination problems. Then Yoshika, Anjurul, and the rest of the team could help people all around the world get clean water. So underneath the caption, it says the engineers hope their solution will help people in Dhaka and all over the world access clean water. So that is really, really good work that they do. And so engineers can really help people all over the world by designing their systems. Okay, so let's see how our timing is doing. I think we're about up for time. So if by chance you finish this early, you can work on the science IXLs. There's some for chapter 1 and some for chapter 2. And if not, you can do other science IXLs, or if you had work that you had to finish from another class, you could do that as well. Okay, I know I missed you today. Hopefully I come back with a 2 tomorrow. And good luck with everything. And I can't wait for you guys to earn the axolotl tomorrow. I hope it's going to be a good day. All right, take care and I'll see you. Bye for now.